Hello and welcome to Securing the Grid. I am Anupam Gaur, and in this first episode, we are stepping into a word most people never see, the word of operational technology or OT. If you have ever wondered how power plants, factories, pipelines, or even railway systems they keep on running safely and efficiently, the answer lies in OT, which is operational technology. So these systems they control the physical processes that make modern life possible. And today we will explore what OT really is, how it works, and why cybersecurity plays a crucial role in keeping it safe. So let's move on to the first segment. Let's start with the basics. Operational technology, often shortened to OT, is the collection of hardware and software that monitors and controls physical devices, processes, and events in real world. Think about it in this way. Every time a clean water flows from your tap, electricity powers your home, or let's say a train runs on time, OT systems are at work behind the scenes. These systems are designed for reliability and precision. They ensure that pumps, turbines, uh, conveyor belts, let's say, or other machines, they should operate safely and they should operate efficiently. So safety is the I would say the most important aspect in OT. Now OT isn't new. In fact, many of these systems were built decades ago. Some systems are, let's say, they are running from last 50 or 60 years. Uh, Before the internet became what it is today, they were isolated, they were secure by design, and they were rarely connected to anything outside the plant or facility. But in recent years, with the rise of digital transformation, or the modern term is Industry 4.0, OT has started connecting with IT, the information systems that run the business side of operations. That connection brings powerful benefits, more data, better decisions, and automation. But at the same time, it also introduces a major challenge, which is the cybersecurity risk. Because now, what was once physically isolated is digitally exposed. And that's what makes understanding OT and securing it more important than ever. Let's move to our second segment, the building blocks of the industrial control systems. So, what exactly makes up an OT system? Let's break it down into different layers from physical world up to the control room. At the foundation, we have sensors and actuators. We will see those sensors and actuators in the next slide in a visio. So sensors basically they measure physical variables like to measure the temperature, to measure the pressure or speed. They are basically the eyes and ears of the system. Actuators perform physical actions like opening a valve or starting a motor. They are the hands and muscles of OT. Next, we have the PLCs or programmable logic controllers. These are the small, rugged computers that take data from sensors and they apply logic and send commands to the sensors and actuators. They make real time decisions. For example, let's say if temperature rises above 90 degrees, open the cooling valve. So that kind of intelligence or decision making is done by the PLCs. Above that, we have the SCADA systems, the short for supervisory control and data acquisition. SCADA basically it allows operators to monitor and control processes remotely, often across large areas like power grids or oil pipelines. Then HMI is also called human machine interface. Uh, that's the dashboard for the operators that shows what's happening in the system and allows them to make manual changes if necessary. So all these components work together, forming what we call an industrial control system. Together, these layers bridge the digital and the physical worlds, ensuring that industrial operations remain precise, safe, and efficient. This is the high level view of how an industrial control system looks like. You have the historian computer engineering workstation HMI connected to a switch, and then that particular switch further connects to the controller, which is the PLC, and the PLC is further connecting to the field devices, to the sensors, to the actuators. So that's a very high level diagram of the industrial control system. Now that we know what OT is made of, let's make uh, talk about how is it different from the information technology or IT. So IT and OT, they have a common goal. They share a common goal, keeping operations running smoothly, but they approach it in very different ways, I would say. In IT, the focus is on data. So storing the data, processing the data, or analyzing the data, or protecting the data. So that is the prime focus in IT. Uh, we will see in the coming slide about the CIA triad. So in IT specifically, the priorities revolve around confidentiality, integrity, and availability of the information. In contrast to IT, OT, the focus is on the physical processes. So controlling machines, ensuring uptime, or maintaining the safety of the equipment or the personnel. The biggest concern in OT is availability, because downtime doesn't mean lost data. It can mean a halted production or equipment damage or even safety hazards. So both IT and OT, I mean, they have different goals, I would say. One is for IT specifically to manage and protect information, for OT to control, protect physical processes. Main priority for IT is confidentiality. For OT, it is availability and safety, the update cycle. So in IT, we see, like, for example, you have Windows patches available quite frequently, and we upgrade those patches on Windows systems. On firewalls, you have patches available. So the frequency is I would say in IT, the frequency is to upgrade the patches is quick, I would say. But in comparison to IT, because the stability demands are more in OT, it's quite infrequent. In terms of lifespan, a firewall, for example, can have a lifespan of 5 years or 6 years or 7 years, but in OT, it is comparatively quite long. I would say 30 years, 20 years minimum. That is the lifespan of the OT devices. And because OT systems, they often run 24 cross 7, uh, the OT engineers or the department who is managing the OT equipments, they are a bit hesitant to change or to patch them, even if there is a security risk. If a control system stops working, an entire factory or a power plant could shut down. So the risk is quite high. So when IT and OT converge, it's not just a technical challenge; it's a cultural one too. Cybersecurity professionals and control engineers, they have to collaborate. They have to learn from each other. They have to understand each other's priorities to find the right balance between security and reliability. So convergence will always bring challenges, which I highlighted here. Let's move to the CIA triad. So if you are familiar with cybersecurity, you have probably heard of CIA triad. CIA stands for confidentiality, integrity, and availability. These are often considered as three pillars that guide the information security. But in OT, we reorder that triad. It becomes availability, integrity, and then confidentiality. Excuse me. In IT, confidentiality comes first. You want to protect, like I mentioned before, you want to protect the sensitive or confidential data. But in OT, the first priority is keeping the process running. A shutdown can have real world consequences, for example, loss of production, equipment damage, or even safety incidents. Let's look at an example. Imagine a water treatment plant. If the control system is taken offline by a cyber attack, even temporarily, let's say for 5 minutes or 10 minutes, the city could lose the clean water. So that's not a data problem. That's a public safety concern. The second priority is integrity, making sure data and control signals are accurate. If temperature reading or let's say a valve position is altered by an attacker or a cyber attack, operators could make unsafe decisions. So integrity is very important. And finally, confidentiality, while still important, we cannot ignore confidentiality aspect, but it is less critical compared to keeping the systems safe and available. So in OT, cybersecurity is not just about protecting information, it's about protecting people, equipment, and the environment. It's about safety through security. So that's the security priorities for OT. Let's move to the last section for today's podcast. Why OT security matters now. Uh, the lines between IT and OT are blurring faster than ever. Factories, power grids, and critical infrastructure are now more connected, more data driven, and unfortunately more exposed. So, cyber attacks that once targeted traditional IT systems are now reaching the industrial world. We have seen incidents in the past, like the famous Stuxnet, Triton, or Colonial Pipeline attacks. So each of these attacks they show us how a single cyber event can disrupt physical operations on a massive scale. These incidents are wake-up calls. Basically, they remind us that OT security isn't optional. It's essential to national security, economic stability, and public safety. So securing OT starts with understanding it. So if we don't understand what OT is, we won't be able to secure it. So that's exactly what this series aims to do, breaking down the technology, the risk, the real world strategies that keep our technical systems safe. So that's it from today, guys. Let's recap today's episode. So operational technology is what controls the physical world from manufacturing to power grids. It's built from layers of sensors, actuators, controllers, and monitoring systems. IT and OT they differ in goals and priorities. One protects data, the other protects uptime and public safety or the equipment safety. The CIA triad in OT puts availability first because safety depends upon availability. And as the digital transformation continues, OT cybersecurity is no longer optional. It's mission critical. So in our next episode, we will look at real world OT cyber incidents, how they happened, what lessons they teach us, and how organizations uh, can build the resilience against those future cyber attacks. So that's it from my side, guys. Thank you for listening, and remember, in the word of OT, security is safety. Thanks a lot. Thank you. Bye bye.